What's going on, guys? In this video we are going to be discussing one of my favorite features in Python, decorators. Decorators allow you to modify the default behavior of functions or classes, but in this video we are going to be focusing on functions. So they're basically wrappers around functions, and these wrappers are modifying the original function. Now, to really understand decorators, what we need to do is first understand functions in Python, because that's going to be an integral part of decorators. Alright, so let's get a better look at functions in Python. So the first thing we're going to do is import time. And if you see the two different functions, my function and my longer function, they're basically the same function except that they are sleeping for a different amount of seconds. So my function will sleep for 1 second and my longer function will sleep for 3 seconds. Alright, simple functions. So the one thing we want to know about functions is that they can actually take other functions as parameters. This is because in Python, functions are actually objects. So we can have a function who takes as a parameter another function. And that's exactly what we're doing with time checker. So time checker will take a function, then it will use time.time to get the beginning time, then it will run the function with the output result, and duration is just going to take the current time minus start time. So what we're doing is we're trying to see how long it takes for a function to execute. So time checker will take a function and we're going to see how long it takes to execute that function. So we can have functions that take other functions as parameters. So that's a pretty cool feature of Python. So let's just test it out, and let me just go back up here and make sure I'm running all these cells. Okay. Alright, we're going to run time checker with my function. Okay, so here, if we go back up, it says if duration is greater than 2 seconds, we'll print out a message. So with my function, the duration was only 1 second, so we didn't print out anything. My longer function is going to sleep for 3 seconds, so the duration is going to be longer, and we should get back the function was running for more than 2 seconds. Alright, so as you can see, we're feeding in a function into time checker and we get back a result. So let's just go back up here and take a closer look at this. The output we're getting back is the result, and the result is actually the function result. Now, instead of getting back the result, what if we were to get back a new function instead? So this is the same exact code as the time checker above, except that the body of time checker is within another function called new function, which is an inner function. So we have time checker, and all of the contents of time checker is now in new function. And instead of returning the result, we return the new function. So this might be a little confusing, but basically we're taking a function, modifying it, and returning a new modified version of the function. So instead of just returning the result, we're returning back a modified version of a function. So we're getting one step closer to decorators. Alright, so we have time checker taking in a function. So let's just test it out. Actually, let me just run this. Alright, so time checker is going to take our my function, and now we're going to get back modified my function, which is actually a modified function. And now we're going to call or run this modified function. And once again, we get foo42 because it only takes 1 second to run this function. Now we're going to create another function called newLong function, which is going to be fed into time checker. I should have named the newLonger function, but it's too late now. Alright, so the function was running for more than 2 seconds. So we have a new modified version of a longer function called newLong function. Alright, so as you can see, the results are the same, but instead of getting the result back, we actually have a new function and we can call that. Now, one of the downfalls of this is that we have to manually assign, for example here, time checker, my longer checker has to be assigned to newLong function. Or we have to assign time checker, my function, to modified my function. Now, instead of assigning them to new variables, decorator allows us to just decorate the original function. So here's an example of a decorator syntax. So instead of feeding in my function into time checker and creating a new function, we can just decorate the original function. So all we need to do to decorate it is use @ and the name of the decorator on top of the function itself. So @timeChecker is the decorator syntax, and we're decorating my function. Now if you scroll down a little bit or you look down to the next function, you'll see that at time checker is also decorating my long function. So instead of taking my long function, creating a new variable, we can actually modify the original functions. So let's just run this. All right, so now we're going to run the two functions. So as you can see, these functions are the same as when we created variables of the modified functions. So decorators are basically the same thing. It's just, I guess, more concise syntax. All right, so now that we have a basic understanding of decorators, how decorators are created, and the syntax for decorators, let's take a look at different types of decorators and the usages. All right, so we have 4 types. We have basic, then we decorate a function with parameters, then we have a decorator parameter, and then we have metaclasses and singletons. So we'll go through each of these except for the 4th one, metaclasses and singletons, because I haven't gone over object-oriented programming with you guys. Alright, so basic decorator. So this is the easiest way to use decorators. We just saw an example of this, and we're going to look at another example. So this is called debug, which is the decorator, and then we have the inner function, run function. And all we're doing is printing start and end before we run the function. So we start, we run the function, print end, and if there's a result from the function, we return that. All right. So we run this, and then we run main, and then we get start, and then we run the function. And here, since we're just printing something, we'll print out the test, and then we print end. So once again, this is just a basic decorator. Alright, so now we're going to get a little more intermediate. Now we want to decorate a function with parameters. Alright, so we have time checker, which once again takes a function, and you can consider this the decorator. But now if you notice, our inner function is actually taking in a parameter, and here we're taking in seconds. So print I'm going to sleep for seconds. So we're going to use a parameter in the print statement. Then we're going to return the result of the func and seconds, and we're going to return inner function, which is just a function. So once again, this is the same syntax as decorator, except that inner function is going to take seconds, or a parameter. Alright, so let's see how this works. Alright, so now we have a myLonger function with a parameter. So we have a function with a parameter, and let's just run it. And all it does is print out the parameter and return 42. Alright, so now we're going to actually decorate myLonger function, which takes a parameter, and as you can see, it's the same syntax. So even though time checker is taking in a parameter, we don't have to do anything special. We just feed in a function with one parameter. And we run this, and we run myLonger function now with the parameter. And I'm going to sleep for 3 seconds, 3 and 42. So the inner function runs with no problem. So let's just take a look at what's going on here. So the time checker takes in a function. However, the inner function takes a parameter. Now what's cool about this is that the parameter that we feed into the function, so for time checker, here's the parameter that we're feeding into the function, automatically gets passed down to the inner function. So the inner function can actually access the parameter that we feed into the time checker function. So we feed into time checker a function with a parameter, and the inner function can get access to that parameter, and then we can run a function with that parameter. Now this is going to lead to problems if our function has multiple parameters and our inner function can only take one parameter. So in this case, our inner function can take one parameter, and the function that we're feeding into the decorator takes one parameter as well, param. So in this case, it works out. However, if we decorate a function with multiple parameters, inner function is going to run into a problem. So for that, we need a way to handle variable amount of parameters. And this is where args and quargs comes into play. So args and quargs allows us to handle variable amount of parameters. So if we have our new function taking in args and quargs, this allows us to be a little more flexible with our decorators. So our decorators can take functions with variable amount of parameters. So if you look at this time checker, it's basically the same thing now, except that new function is taking args and quargs instead of a specified parameter. And we can feed these instead of a specific amount of parameters. And now we can feed these args and quargs into our function and still get the result. So once again, I've done a video on args and quargs. If you guys don't know what args and quargs are, I suggest you look at the Python playlist and find the video. Alright, so I'm going to run this. Alright, so as you can see, we only have to add args and quarks to handle variable amount of parameters. Alright, so we're going to decorate now my longer function. And here my longer function is going to take 2 parameters. And we're just going to have print statements with those 2 parameters. Alright, so it's still running. Okay, so I'm sleeping for 3, my additional parameters is foo, and the function was running for more than 2 seconds. So as you can see, we decorated the function with 2 parameters and we had no problems. Now we're going to decorate the function time checker with 3 parameters. And once again, we'll have no problems. I'm sleeping for 3, my additional parameter is foo, my second set of parameters is bar. So we're able to decorate and run functions with a variable amount of parameters. Alright, type markdown, I'm not sure what that is. Alright, so now the next use case, a decorator with a parameter. So earlier we just saw a function with parameters, but now we're going to actually have decorators with parameters. Now this is an advanced usage of decorators. It's not actually intuitive to call a decorator with some parameter. So as you just saw, the code at myDecorator decorates a function, which is the same thing as creating a new function, myFunction, and you are feeding the myFunction into the original decorator, myDecorator. Alright. So now the problem with this is that your parameters is explicit in the sense that you can't add any other parameters other than the function. So with decorators, you're limited to actually one parameter, your function itself, and you can't feed in other parameters. So we have to be a little more clever about this, and Python allows you to do so. And the way you do that is you actually decorate your decorator. So if you look at this massive function containing 3 functions, you'll see that the new function is the innermost function, the decorator is the decorator, then we have a time checker, which is a decorator on top of the decorator, taking in max seconds. So the decorator is the decorator, but then we have a time checker taking max seconds, which is going to allow us to feed in parameters into the decorator. So very simple, we have a decorator and then we just add another outer function to the decorator and we feed in the parameter that we want to feed into the decorator. And if you look at the return statements, the decorator once again returns the inner function and the time checker, which is the outermost function, is going to return the decorator. So it's essentially the same thing, just with another layer of a function. Alright, so now we can actually feed in parameter into time checker. So if you look at the syntax, it's basically calling time checker with an additional function. So instead of just running the decorator at time checker, we're actually calling time checker with an additional function and feeding it too. Alright, so this is basically allowing us to feed in a parameter into our decorator. Alright, so if we go back up, let's look at how max seconds is used. If duration is greater than max seconds, we're going to print out a function. So since our sleep is 3, the duration is going to be greater than the max seconds of 2. We're going to get back the function was running for more than max seconds, which is 2 seconds. So let's just run this. Alright, so foo, this function was running for more than 2 seconds. And now we're going to feed it in 4 seconds into time checker and run this. Okay, so max seconds is 4 seconds and we're only sleeping for 3 seconds, so we should not get back the function was running for more than 2 seconds, or in this case 4 seconds. So as you can see, we don't get back a message that the function was running for more than X seconds. Alright, so next up is metaclasses. Now we're actually going to skip this as I haven't gone over classes yet. So skip this, and we get to other examples. Now that we know how to use decorators, I want to show you guys some more examples of decorators and some cool things you can do with it. Alright, so these are just some simple examples. You can check the type of parameters. Alright, here, so we're going to use a decorator to check if the first parameter is a string or not. So this can be thought of as type checking. So we want to check if the first parameter is a string or not. So we have a decorator check string, which takes in a function, of course. The function will take in args and quarks. Now, here's where the difference is. So first param equals args 0. So all we're doing is accessing the first parameter, and we're going to check if it's an instance of string. So if it's not an instance of string, we raise an exception, or else we just return the result, and that's it. So we raise an exception if it's not a string, or else we just return the result. So we run this, and now we're going to use check string on myLong function. So we're going to decorate myLong function, All right, so my long function, and now we're going to pass in a string. So no problems. Here, as you can see, we get back foo and 42, so nothing was raised. However, if we put in an integer, our check string is going to actually raise an exception, not a string. So as you can see, when the first parameter is in a string, we'll raise an exception. So that's what check string was doing. All right, so now we have multiple decorators. This is pretty cool. You can actually decorate a function with multiple decorators. All right, so we have two decorators here, debug and debug2, and they pretty much do the same thing. We just print start, we run the function, print end. If there's a result, we return the result. So the same thing with debug2. We print start. If there's a result, we run the function, and then we print end2. So we have debug and debug2. Now, once again, we have my long function, and here we're going to decorate it with debug and debug2. So let's just see what happens. So we have my long function, and my long function is just going to print the parameter. So let me just run this. Let me run my long function. All right, so let's see what's happening. So first it prints start, then start2, foo, end, end2. So pretty much we're seeing a sandwich of decorators. So let's just see what happens. So it first starts off with start, which is from debug. Then it gets to start2. So let's go to debug. We print start, and now we call the function with args and quarks. So what we're actually doing when we call the function is debug is calling the next decorator debug2. So debug is calling debug2, which is what's happening here. So we have start, then start2. Now debug2 is going to print start2, and then it's going to actually call the function which it's decorating, which is my long function. So my long function sleeps for 3 seconds and prints a parameter. So we have start, which is the first decorator, calling the second decorator. The second decorator runs start, and then it runs the function, which is going to print foo. So it runs the function, which is going to print foo, and then it ends. And then once this ends, it returns the result, returns new function. It goes back up to the earlier decorator. Since the early decorator was calling decorator, and we finished the second decorator, debug2, we're going to print end. So once again, let's look at it. We have start, which is the first decorator, and then it calls the function, which is the second decorator. So we have to wait for the second decorator to finish. And of course, the second decorator is calling the inner function foo. Then the second decorator finishes. And once the second decorator finishes, start, which is the first decorator, will be followed by end. All right, so that's the use case of double decorators. All right. Now, this is because the execution is stacked, of course. We have debug, followed by debug2, followed by function. All right, so we have a couple more examples. We have changing the result of a function. So here we're going to apply a change to the result of a function. So once again, we have a decorator with the inner function, except that instead of returning the result, we can actually make modifications to results. So here we're going to return result.upper, and then return the new function. All right, so we have a function which returns foo, but our decorator is going to modify it and return foo. So you can see that the result of the function has been changed in the decorator, and this can be very useful in some web frameworks. So we can actually modify some text to be a header in HTML or a paragraph. So we can actually enclose text with HTML tags. So that's one use case of decorators. All right, so finally, undecorated hack. So what happens is once you decorate a function, you can't really access the original function. You only have access to the decorated function. So I kind of wanted to know how you can access the original function despite decorating the function. And the way you do that is with a closure hack. So you can actually still access the original function. So once again, we have a decorator time checker. So I'm going to run this. Okay, so we're going to decorate my longer function. And as you can see, this is going to be a decorated version. The function was running for more than 2 seconds. So as you can see, this is from the decorator itself. So my longer function has been decorated with time checker. Now, if I want to access the original function, my longer function, what you need to do is call my longer function or access the attributes of my longer function. So my longer function's dot closure attribute, and we get the 0th index of the list from the closure attribute, and then we call cell contents. So if I run this, so let's just say, okay, so we have original function, So we're going to actually access the original function, and now let's just call the original function, which is going to be the original myLonger function. Alright, so as you can see, foo and 42 without the decorator, as opposed to here, myLonger function and the decorator. So this is how you undecorate, not actually undecorate, I should probably say access the original function from a decorator function. Alright, so those are pretty much the basics of decorators. There are a lot more examples I could have gone through, but I've decided to keep this, I guess, somewhat short. If you guys have any interesting examples of decorators, you're more than welcome to post that in the comment section. Or if there's something further you want to see with decorators, just post some comments within the comment section. And if there are any other types of videos you want to see, you can post that within the comment section as well. Finally, there's just additional resources, Stack Overflow, Medium, and there's a bunch of other resources as well that I used. But these are additional resources. So if you want to look at more functionality or common uses, the first one is pretty good. Common uses for Python decorators. You guys are more than welcome to check that out. Alright, so that's it with this video. I will see you guys next time.